Hello everyone, welcome back to my channel Shah Sir classes. I am Shah Sir here. My dear students, today I am going to continue with the chapter of class 10 metals and non-metals. In our previous class, we have discussed what are metals and what are non-metals, and we have found the difference between metals and non-metals, and also we have gone through the physical properties of metals and non-metals. Along with that, we have discussed, that is, how the metals are going to behave when they are going to react with some other elements. Like when it is going to react with water, how it's going to behave. When it's going to react with non-metals, how it's going to behave. When it is going to react with air, how it is going to behave. When it is going to react with steam, how it's going to behave. And also the formation of sodium chloride, magnesium chloride, and aluminium chloride. So these are the things we have discussed in our previous class of metals and non-metals part 1 video. Yet if you have not watched that video, no worries. In the below description, I'll share you the link of that. You can just go through that video, okay, so that you will get the better clarity of this chapter. And do not forget, in this session, we are going to cover each and everything related to this chapter, metals and non-metals. We are not going to leave even a single scratch related to this chapter. And also, it will be like a crispy notes for you guys, okay, so that it will be helpful for you while you are writing the answers in the given in the questions, whatever the questions they are going to ask in the exam. Okay, as you can see, the whole textbook itself we have made as a crispy notes so that it will be helpful for you even to understand, along with that to write the answers also. Now we'll go ahead with ionic compounds. Now, what do you mean by ionic compound? As you can see, the compounds formed by the transfer of electrons from a metal to non-metal. Yesterday we have seen, right? Sodium has transferred the electrons to chlorine in the formation of NaCl. Am I right? Yes. When a metal is transferring an electron to its nearest non-metal, then what happens? One new compound will be formed. That new compound is known as ionic compound. Clear? So sodium was a metal. It has transferred the electrons to a non-metal, that is chlorine. When metal is transferring a electron to the non-metal, one new compound is formed. That new compound is sodium chloride. Am I right? That sodium chloride is called as an ionic compound, or it is also called as electrovalent compound. Ionic compound or electrovalent compound. Now example of ionic compound is sodium chloride is an ionic compound, magnesium chloride is ionic compound, aluminum chloride is ionic compound. What is this all? It's nothing but all the metals are transferring, whichever the metals are transferring the electrons to a non-metal. Understood? Then the new compound which will be formed, such a compound is said to be ionic compound. Clear? Sometimes directly they can ask you what is ionic compound. If not, sometimes they will give you in multiple choice. Both they will give metal metal. Do you think that metal can transfer electron to a metal? No, because metals are electron donors. We have discussed yesterday's class, right? Metals they know only to give. Non-metals they know only to take. Am I right? All the metals are donors and all the non-metals are acceptors. Clear? If someone is giving, the opposite side, someone should be there to take. Then only ionic compound will take place. I am giving, even he is also giving. Then ionic compound will take place? No, no ionic compound will form. When the ionic compound will form, someone should give and the other one should accept to form a stable compound. To form a stable compound. So only in that scenario, the ionic compound will be formed. Any doubts? Both are accepting. Ionic compound will form? No. Both are giving. Ionic compound will form? No. One should give and the other one should accept. Then only ionic compound will form. And we will see the properties of ionic compounds. Yeah, children. Now we are going to discuss the properties of ionic compounds. Children, this question is one of the most important question of this chapter. In most number of times, this question has appeared, and also this question will appear in your passing package also. 100% sure they will ask you this question. Sometimes write any two properties of ionic compounds they will ask. Sometimes just they will mention write the properties of ionic compounds. Then you are supposed to write this answer. It is one of the most important question. Again I am repeating. Okay, let me see what are the properties of ionic compounds. Number one, physical nature. What do you mean by physical nature? Physical nature means how they appear, how they look. Are you getting my point? Yes. How they look, what we see, how we see them. That is called as physical nature. Here the physical nature is they are in solid state and also they are hard. As soon you see the ionic compounds, they will be hard, they will be solid and generally brittle. What do you mean by brittle? Brittle. Yeah. So children, the brittle means it will be easily broken. Understood? For example, you take a glass, you drop the glass, it breaks into small pieces. You don't need to apply any external pressure to break that. It is hard, but they are generally brittle. They can be easily broken. Next, melting and boiling point. Now, what is the melting and boiling point of these ionic compounds? They have high melting and boiling point. My dear students, this word is very important and this will be the answer for few give reasons questions. For few give reasons questions, this sentence is very important. We are going to use this sentence while we are answering certain give reasons questions. Later I'll tell you which are the types of give reasons questions will come based on ionic compound. If they ask you some question, you have to give this answer. What should be the answer? They have high melting and boiling point. So this sentence is important. Remember, high melting and boiling point means they are easily not melted. We have to give maximum temperature to melt them. Maximum temperature should attain to boil them. Understood? They are not so easily changeable. We cannot change them. Their form. And solubility. Generally, they are soluble in water. Yeah, see the beauty of the nature. See, if you want to melt them, you want to give very high temperature, then they will melt itself. But they are soluble in water. You drop in water, they will get melted. They are soluble in water. Understood? But insoluble in solvents such as kerosene, petrol, benzene. In these all solvents, they are not going to dissolve. Are you getting my point? If you want to solve them, dissolve them, which is the chemical we have to use? Water. They are soluble in water, but they are not soluble with some insoluble solvents such as kerosene, petrol, etc. Understood? So in these all, they are not going to dissolve. So that usually we use them to store. Usually to store them, we use this insoluble solvents. In these insoluble solvents, they are not going to react. That is the meaning. Now come back to conduction of electricity. Ionic compounds conduct electricity in molten state, in molten solution. Ionic compounds, they conduct electricity, means understood. See here, NaCl if you use, once if you are going to add with a chemical, yet after dissociation, NaCl, when it's going to react, Na will come separate, Cl will become separate. It means that they form ions. What they form? Ions. They form ions. Since they form ions, so that we are going to use them in the conduction of electricity. Understood? Ionic compounds क्या होती है बेटा? ब्रेक होने के बाद आयोन्स में कन्वर्ट होती है. आयोन्स का मतलब एक पॉजिटिव और एक नेगेटिव, दो फॉर्म में कन्वर्ट होने की वजह से वो क्या होता है, करंट को पास करने में या करंट को जनरेट करने में हम इसको यूज करते हैं. यूजुअली वी यूज दिस इन एसिड्स, I mean batteries. You have seen the battery, right? In the battery you have seen, right? We use acids, they tell, right? Yeah, means they form ions. After dissociation, they form ions. So, my dear students, ionic compounds conduct electricity in molten state and also in solution form, but not in solid state. If you want to conduct them in electricity, you should use molten form, molten state. What do you mean by molten state? Molten means it is neither a solid nor a liquid. It's a mixture. Understood? In that state, they will conduct electricity. Ionic compounds conduct electricity in molten state, not in solid state. In molten state, after dissociation, they form ions. Due to the formation of ions, we are going to use them to conduct electricity. So this will be your give reason question. This could be your give reason question. What may be the give reason question? Ionic compounds conduct electricity in molten state. Why? Give reason. Why? Ionic compounds, after dissociation, they form into ions. They convert them into ions. Ions will be formed. These ions helps in the conduction of electricity. Understood? Sometimes they will ask you the question like this. Ionic compounds conduct electricity in which state? Name them. In which state? And give reason. In which state they conduct electricity? Water state. Give reason. You can write this. After dissociation, they form ions. After dissociation, they form into ions. Any doubts? Very good. Now come back to the next topic. Occurrence of metals. How the metals occurs? Now occur means what? Occurrence is nothing but how do we get them? हमना वो कैसा मिले? ಯಾವ ತರ ನಮ್ಗೆ ಅದು ಸಿಗುತ್ತೆ? That is occurrence. Occurrence of metals. Understood? Understood? Naturally how they are going to obtain? हमना nature से हमना वो किस तरह से मिलता है? How do we get that from the nature? समझ में बेटा? Origin. कहां से वो start हो रहा है? Now, before understanding the occurrence of metals, we need to understand here some two topics, minerals and ores. This is also one of the most important question for exam. Definition. What are minerals? Or what are ores? They will ask you this question. But sometimes they will ask you the question this also. Write the difference between minerals and ores. Write the difference between minerals and ores. This also could be the examination question. Great. Now let's see what do you mean by mineral. So minerals are nothing but the elements or compounds which occur naturally in the earth crust. Below the earth, if this is our earth, this is the region of our earth and this is our atmosphere. Below the region of our earth, this layer we called as earth crust. Below the earth region, if this is the earth, below this is earth crust. We have the earth crust. The elements or compounds which occur naturally in the earth crust. Zamin khodo, dig the earth, go in deep, we find the earth crust. In that, whatever the compounds we are getting or whatever the elements we are getting, those all elements we call them as minerals. You understood my point? Yes, yes. So minerals are obtained naturally in the nature. How? How do we get them? From the earth crust. We get them from the earth crust. From the deeper section of the earth, we get it. That is minerals. Similarly, my dear students, what do you mean by ores? What is ore? Ore is nothing but okay, minerals that contain very high percentage of particular metal and the metal can be profitably extracted from it. Such minerals are called as ores. See, ores also we are getting from minerals only. Ores are also getting from the minerals only. But there is one specific condition. What is that condition? Minerals that contain very high percentage of that particular metal. For example, see here, I'll give a small example. Now, this is my layer of the earth. Okay. Let's say this is my earth crust. Just a minute. This is my earth crust. In this earth crust, I am finding some minerals. Correct? Yes or no? I am finding some minerals. In this minerals, I will just zoom one part. Up, just can you see this which I have encircled? I am zooming this. In this mineral, some quantity, maximum quantity of only one metal is there. Maximum. Can you see this? This much. This much quantity of only one metal is present. Example, let me take iron. Iron is around 80%. Only few percentage, can you see this? Only few percentage, some other metal is obtained or some other impurity is present. Maximum quantity of metal is here. Only few quantity of some other, either might be some metal or some other impurity is present. You understood my point? Now one more example. Let me to zoom one more mineral. Let me take one more mineral. Now this is one more mineral. In this In this, some quantity of one metal is present, and some quantity of another metal is present, and some quantity of another metal or some impurity is present, and some quantity of let me say some another quantity of another some substance is present or some element is present. Now you can see the example of both the sides. This is case 1 and this is case 2. Are you getting my point? Now in case 1, maximum percentage of metal is present. Some any metal, either it is iron or copper or silver or gold, whatever may be. Maximum portion of metal is present, and here not maximum, we have a mixture. In this case we have a mixture of some metals or some non-metals. Mixture of some elements or compounds are present. Now, this is called as ore, not this. This is not an ore. This is what the definition of ore states. You understood the meaning of ore here? See, ore also we are getting from the earth crust only. But only the difference is what? Minerals that contain very high temperature of particular metal. Particular, only that metal. Maximum percentage of or maximum portion of only that metal is present in that mineral. Understood? And that metal can be profitably extracted. After purification, we have different process to purify. Understood? We have different process to purify. I'll tell you. We have different methods to purify different metals. All metals we cannot get it from the same method. Now I'll tell you for example. If you want to let's say uh, cut the tomato into small pieces. Knife, with knife also we can cut into small pieces. We can choke them into small pieces, right? Even with the knife. Yes or no? We can cut. Okay. You take coconut. Can you grind it into small pieces by knife? No, we can't. So we have to use mixer grinder. So by using mixer grinder, we can cut them into small pieces. Tomato, knife is sufficient to cut into small pieces. So knife is one method to cut into small pieces. Coconut, we are using mixer grinder. That is sufficient. That method is required to cut that into small pieces. Like this also, to extract pure metal from its ore. To extract pure metal from its ore, we are using different methods. Different types of methods are there to extract them into its pure form. You understood my point now? Understood the meaning of this? So all cannot be extracted with the same method. So we have got different methods to extract them into its pure form. You understood the difference between mineral and ore here? Yes or no? Do you think ores we get separately from from some other place? No. Minerals from where do we get? Earth crust. Ores from where we get? From earth crust only. Ores also we are getting from the earth crust, but only the condition is they are coming from the minerals, but maximum portion of that metal should present in that. If maximum portion of the metal, if it is present in that mineral is called as ore. That mineral we call it as ore. Clear? I hope you have understood now. Sometimes they may give you some indirect question also, children, based on mineral and ore. You have to be very careful with respect to that part. Okay, I hope you have got a crystal clear clarity about the concept of mineral and ore. Yes, sir. Sure? Very good. Now, look at here, children. Do you remember the reactivity series which we have discussed in the previous class? Reactivity series, do you remember? का ना खाले को म्हणजे आलू लाना. जिद करे तो लोहा पकड़ को घर में घुस को कुत्ते को मारे जैसा मारतो. हाउ जी लास्ट में आओ बोल को डकार देखो जो जी. Remember, right? That's what. Reactivity series. Now, can you see this K, NaCa, MgAl? These metals are very reactive metals. Very reactive metals. These metals are very reactive metals. They are not found in free state. Wherever you go, they are not available. You cannot obtain them in its free state. And to obtain that, we are using extraction by electrolysis method. This is the method we are using. That we also called as electrolysis method. Which method we are using to extract them? If you want to extract them, we got it ore. Potassium ore we got, man. Calcium ore we got, or sodium ore we got. No, I want that ore into its pure form. तो मुझे प्योर फॉर्म होना. प्योर फॉर्म का मतलब क्या? उसके अंदर जो भी impurity है हम उसको बाहर निकालना. We have to remove the complete impurity out of it and we have to obtain its pure state. You understood my point? So to obtain that, we are using electrolysis. We are using electrolysis method. By using electrolysis, we can obtain them in its pure form. Next is they are moderately reactive. Moderately means average. Not so highly reactive, not slow reactive. It's moderate. Those are zinc, iron, lead, copper, mercury. So these occur in sulfides. In which form they are available in the nature? They are available in the form of sulfides, oxides and carbonates. In this form they will be available. By using from that particular form, we have to extract them into its pure. Clear? Now, which method we are using to extract them in its pure form? Reduction by using carbon. Reduction by using carbon. Next, they are least reactive. Which are least reactive here? Gold, silver. Understood? And even you can tell platinum also. These they occur in native or free state. They are available in free state. Understood? And one more definition will come for free state. Free state is nothing but in which form they want, max to max, they will be available in its pure form only. Whenever we are extracting them, they are available in its pure form. So very less efforts are required for them to filter. समझ में बेटा? Understood? Yeah. See students, what do you mean by free state here? For example, if you extract the above metals like sodium or potassium or calcium, any such type of metals, okay, when we find its mineral or ore, देखो बेटा जो भी हमना जो ore मिलेगा या जो भी हमारे को मिनरल मिलेगा वो क्या होता है किसी और के साथ मिक्स होके रहता है. Understood? Some part of that metal is present and some part of some impurity is present. Some part of the impurity is present. By using extraction process, we remove this impurity. By using extraction process, we remove this impurity and finally we obtain the pure form of that metal. समझ में बेटा? वो जो मेटल है वो किसी और के साथ कंबाइन होकर है. It is combined with that. Now we want to remove that unwanted thing and we have to extract the pure form. Understood? Here gold and silver, in the case of gold and silver, they are occur in free state, means they are not combined with some other metal or some any other element. They are not combined with some other element. They are something like ready to eat. You no need to filter them, you no need to cook them, directly remove, start having it. That is called as they are available in free state. Understood the meaning of free state or native state? They are not combined with some other elements. They are already present in its pure form. Concepts are clear? Sure? Very good. Understood which are the very highly reactive metals, moderately reactive metals, and least reactive metal. How can you extract least reactive metals? Which method do we use to extract them? Which method are we using to extract? See, as I said you, very highly reactive metals we use electrolysis method, and moderately reactive metals we use reduction method, and least reactive metals which method are we using? We don't want any method because already they are in pure form. Then why you want any method? This will be the give reason question. Understood? Understood? If they ask you name the method through which we can obtain pure gold, which method is required? No method is required. Why no method is required? Because already they are present in its pure form, or if they are already available in its free state. So we don't want any method to extract them. I hope that you have got the clarity about the topic. Am I right? Now, still more in detail, we'll study about this extraction process. Very interesting. Extraction of metals from its source. It follows three steps. How many steps is required? Three steps to extract them in its pure form. Except your least reactive metals, highly reactive metals, moderately reactive metals, what we have discussed right now. अब हमें जो डिस्कस किए थे बेटा हाईली रिएक्टिव मेटल मॉडरेटली रिएक्टिव मेटल अब हम उसको प्योर फॉर्म में किस तरह लाएंगे हाउ कैन वी ऑब्टेन देम we follow these three steps. The first step is enrichment of ore, second step is extraction of metal, and third step is refining of metal. Enrichment of ore, extraction of metal, and refining of metals. Understood? That is nothing but concentration of ore. Can you see here? So how do we concentrate the ore? First, we have metals with very highly reactivity. Case 1 we have studied, right? And metals with moderate reactivity, just now we have seen right here. Remember, very highly reactive metals. This is moderately means medium reactive metals, and these are least reactive metals. Yeah, I hope you have understood, right? Yeah, this is what I was discussing here. The step 1 is, remember, metals with high reactivity, metals with, let's say, these are the metals with highly reactivity, and this is the metals with moderately reactivity, that is medium reactivity, and these are the metals with low reactivity. Low reactivity. So here what do we use? We are using electrolysis of molten ore. How can we extract them? How can we extract them? By using electrolysis of molten ore. Understood? This is step 1, man. Excuse me. I said 3 points we follow. This is step 1, this is step 2, and this is step 3. Clear? Remember here step 1, enrichment of ore. Step 2, extraction of metal. How do we extract highly reactive metals? By using electrolysis we are going to extract. And how are we refining that metal? We are get that pure metal. That is the refining. Okay. Similarly, metals of medium reactivity, we use carbonate ore and we use sulfide ore. Excuse me. We use carbonate ore and we use sulfide ore. So carbonate ore example is zinc carbonate, ZnCO3. How can we obtain this ZnCO3? By using the process called as calcination. Children, this is important. Again, I am repeating, this topic is important. Don't forget. Yeah, students. So this is one of the most important topic. How can we extract the metals of moderately reactivity? We are using two methods to extract them. How many methods we are using? Two methods. The first method is known as calcination and the second method is known as roasting. By using calcination and roasting, by using these two methods, we are going to extract the moderately reactive metals or medium reactive metals. Okay. Now, someone may ask you, what is calcination and what is roasting? When are we using calcination method and when we are using roasting method? Children, remember, if we are going to heat, understood? In the presence of, if you are going to heat, so here, carbonate ore, if we are going to heat carbonate ore in limited air, if you are going to heat carbonate ore, एनी कार्बोनेट और जो भी वर्ड कार्बोनेट से खत्म हो रहा है बेटा उसको बोलते हैं कार्बोनेट और एनी वर्ड इफ इट इज एंडिंग विद कार्बोनेट जिंक कार्बोनेट पोटेशियम सॉरी जिंक कार्बोनेट आयरन कार्बोनेट aluminum carbonate. Are you getting my point? So anyhow, so whatever the metals name, if it is ending with carbonate, that is called as carbonate ore. If you are going to heat carbonate ore in limited air, not maximum air we are supplying, limited air, understood? So that we are getting the metal. After that, we are getting the pure metal. That process is known as calcination. One more question. What is calcination? Heating the carbonate ore in the presence of limited air. That is known as calcination. If we are heating same thing sulfide ore, heating sulfide ore with excess air, excess oxygen, more air you have to supply for that. If you are heating sulfide ore with excess oxygen, more air, more oxygen, then we get the product. This method is said to be roasting. Understood? Calcination and roasting. Calcination using limited air. Roasting, we are using excess air. Calcination, we use carbonate ore. In roasting, we use sulfide ore. Any doubts? Huh. But still, most of you will get confused in the exam between limited ore and excess air. Limited air and excess air. What is the difference? I'll tell you. देखो बेटा, what is the word here? Roasting. Have you seen kebab roast? Fish roast? Roast करना क्या करना? ज्यादा अंगार देना. More fire you have to give. Then only roasting will be there. Chicken kebab. Have you seen the roasting? How do we roast? By giving excess air. By using excess fire, the roasting will take place. Simple. समझ गया बेटा? Understood? Where chicken kebab is very famous? In shadis, marriages, wedding. कहाँ बेटा चिकन कबाब ज्यादा मिलता? शादिया में. That is S. S start from शादी. That is sulfide. शादिया में एक्सेस एयर में चिकन कबाब बनाती बेटा. समझ गया बेटा? ये मेथड को हमें क्या बोलती? रोस्टिंग. सिंपल. शादी में चिकन कबाब बनाने क्या करना? अच्छा रोस्ट करना. कैसा रोस्ट करना? ज्यादा अंगार दे. Roasting. But children, it's not like chicken kebab. Don't write. I just gave the example. Something, some hint, man, to remember. That's it. Nothing else. Follow the concept. Follow the concept. If they ask you write the difference between carbonate ore and sulfide ore. This is what you are supposed to write the difference. So calcination is the process in which we are heating the carbonate ore in limited air is known as calcination. What is roasting? If you are heating sulfide ore in the presence of excess air, the product is formed. This process is known as roasting. Example of carbonate ore, zinc carbonate. Example of sulfide ore, cinnabar. Cinnabar, HGS, cinnabar. ZNS, zinc sulfide. HGS, Hg is what? Mercury. Hg is mercury. Sulfide. That is called as cinnabar. HGS is called as cinnabar. Don't forget this name. And zinc sulfide. Whatever the word ends with S, roasting is the method. Whatever the word ending with CO3, calcination. Any doubts? Now, by using this calcination and roasting, we get the oxides of that metal. After extraction, what we get? Oxides of that metal. These oxides, इनके oxides मिले. अब इनके oxides को हमें क्या करना है? Reduce करना है. By using the reduction to metal, then we reduce that to its pure form. By using the oxides of that metal, we use reduction. We are reducing to its pure form. How? By using purification of metal. By using purification process, reduction process, that is called as reduction. Remember, in the table I have given reduction. Remember or not? I said you here reduction, right? Can you see here? Can you see here reduction? Yeah. By using reduction of metal, we extract that metal into its pure form. Concept is clear? Is the concept is clear? And similarly, reactivity of low metals of low reactivity, we use sulfide ores. We use sulfide ore. You remember, sulfide ore means nothing but roasting. By using roasting, we get the pure metal. To obtain that pure metal, we use refining. Here we use reduction. Here we use same thing. Reduction to metal or reduction to metal, both are same only, man. Again, we reduce to its pure form metal and we use the metal called as refining method. By using refining method, we extract that into its pure form. By using purification of metal, we extract that into its pure form. Nothing else. Okay. So these are the steps involved in the extraction of metal from its ore. From where ore we got? From mineral. From mineral we got ore. From that ore we got a pure metal. In all these cases you can see finally we are extracting a pure metal. Finally we are extracting a pure metal. Okay. Now some important terms. Children, this is one of the most important question. Any of this definition can be asked for in the exam. Sometimes they'll ask you the question like this. Define the following terms. Then they will ask you gangue or gang. Different pronunciations are there. Gangue, gang, both are same. Gangue, roasting, calcination, reduction. These are the basic terminologies in the exam they you can expect. Now what is gangue or gang? These are the ores are usually contaminated with large amount of impurities. Understood? What do you mean by gangue? See here. I told you we have got a mineral. Yes or no? In this mineral, my dear students, in this mineral, maximum quantity of impurity is present. Not metal. Impurity means waste. Maximum quantity of impurity is present. Only few part of the metal is present. Understood? If in any mineral, if maximum quantity of impurity if it is present, a large amount of impurity is present, that impurity usually it will be in the form of soil, sand, in that form it will be. It is not useful at all. Understood? Such substance is known as gangue. Such a mineral is called as gangue. Understood? These are the ores. Actually, this is also nothing but an ore only. Okay. The ores usually contaminated with large amount of impurities. In that maximum amount of impurity, if it is present, such as soil or sand, example, etc., that is called as gangue. Next, roasting. You know very well. The rest now we have discussed, right? The sulfide ores are converted into oxides. Simple. The sulfide ore converted into oxides by heating in the presence of excess air, more air. This is called as roasting. Example, zinc sulfide with excess oxygen, that is O2. If we are going to heat them, we get zinc oxide. Now, my dear students, by using the zinc oxide, by using refining method, we get only zinc. We remove only zinc from that. After refining, we already got zinc oxide. Again, the zinc oxide, by using reduction method or refining method, we remove from ZnO this O and we get pure Zn. We get pure Zne. Understood? Understood? Yeah. Now, what is sulfur dioxide? It's a gas. It will evaporate. We are not going to get it. Okay. Only from the zinc oxide, again, what we do, by using reduction or refining method, we obtain a pure metal. Similarly, what is calcination? The carbonate ore are changed into oxides. Carbonate ore we are changing into its oxide by heating strongly in limited air. Only a few amount of air we are supplying. So this process is known as calcination. As you can see in calcination, as you can see in both these differences, since it was excess air, so O2 was here. Since it is limited air, so there is no O2 here. Can you see the difference? When it was excess air, O2 was there. From Zn in ZnS plus O2 we have used. Oxygen we have used. Because more quantity of oxygen we are using. Here we are not using oxygen. Limited air means we are not using oxygen. So it is only just ZnO3. Sorry, ZnCO3. Only when ZnCO3 is heated, then we get ZnO. Again by using reduction method, we remove this O and we get only Zn. We obtain only Zn. Now reduction, metal oxides are reduced to corresponding metals. Metal oxide means what? ZnO we got, no? Here we got ZnO. Yes or no? Here we got ZnO. Okay. Observe you. In this both the cases we got ZnO, no? By using roasting method also we got ZnO. By using calcination method also we got ZnO. Now what we are doing? This ZnO is nothing but metal oxide. Metal name is Zn, O is oxide. Now this metal oxide, we are reducing them. क्या करें बेटा हम इसे reduce कर रहे हैं. Reduce का मतलब क्या? ZnO से O को निकाल रहे हैं. From ZnO we are removing O. From ZnO we are removing O because I want Zn. Understood? That is called as reduce. reduce to corresponding metal by using reducing agent. What is required? Reducing agent की जरूरत है बेटा. Zn के साथ O है. अब O को please O leave me. He will go. No. To remove them, to remove O, इसके attraction इन्हें किससे अट्रैक्ट होता है उसे सामने ले लेकर ना. तब क्या करता वो? ओ मेरे डियर फ्रेंड करके वो फ्रेंड करने चले जाता, तब Zn बाहर आ जाए. Understood? That is called as reducing agent. To reduce O, it means when metal oxide are reduced to corresponding metal by using reducing agent like carbon. Carbon is one of the favorite of all girls. Understood? Carbon is one of the favorite of all the girls. Now as you can see, Zn and O are best friends. Both are boys. Now if I want to remove this boy, so what I should do? I want to bring one smart girl. Who is she? See, by seeing see this O, oh my dear friend, this CO will go out, only Zn we will get it. For CO, Papa will take care. That is reduction method. Clear? Understood? Understood? So this is what, to remove this O, what I did, I brought C here. What is C here? This is the reducing agent. C is reducing agent. As you can see, ZnO, when it is moving this side, it becomes Zn. This process is known as reduction. Am I right? It was earlier it is C. Now it is becoming CO. This is known as oxidation. Remember, oxidation is nothing but addition of oxygen. Reduction is nothing but removal of oxygen. Oxidation and reduction process. In this reaction, you can see both oxidation and reduction is happening. So it is said to be redox reaction. That is your chapter number 1. Oxidation reaction and reduction reaction. So if you want to reduce, then you have to get reducing agent. आपको reduction होना है तो आपको क्या करना है? Reducing agent को लेकर आना है. That is C. Now here C is the reducing agent which is helping me to remove from ZnO O. Huh. I hope the concept is clear for you all guys. Understood? Sure. Okay. Now come back to the next topic. Refining of metals. What is the next topic? Refining of metals. Actually, we have different processes, but among that, we are discussing only one type here in this chapter. समझ में आया बेटा? That is called as purification of copper. What it is called as? This process is known as purification of copper. Okay. That is also called as electrolytic refining of copper. Both are same. Purification of copper or electrolytic refining of copper, both are one and the same. My dear students, as you can see, here we have a tank. In the tank, can you see this? I am using acidified copper sulfate solution. I have added in this acidified copper sulfate solution, and here I am using two electrodes. One is anode and the other one is cathode. I am using two electrodes. One is anode and the other one is cathode. This anode and cathode is connected with a battery and a key. With a battery and a key. Actually, to speak, if it is single, we call it as a cell. Always positive and negative should be here. Understood? If it is single, we call it as a cell. If more than one cell, if it is connected together, we call it as battery. That we have discussed in the chapter electricity. Am I right? If it is single unit, it is a cell. If it is more than one unit, it is a battery. But here, just for the reference, I will call this as a battery. I will just call it as a battery. And this is the symbol of a switch or plug key. Both are same. Switch or plug key. Understood? Now, as you can see, in this acidified copper sulfate solution, please observe here carefully. In this acidified copper sulfate solution, CuSO4, understood? Now I want pure Cu outside. I want to remove this SO4. I want to remove SO4. I want only Cu. So I am using this method. Why am I using this method? To obtain pure copper. To obtain pure copper, my dear students, I am using the method called as electrolytic refining method. Electrolytic refining method. Now, once if the acidified copper sulfate solution is added here with the connection of the battery, now this battery will discharge positive electrons. This battery will discharge positive electrons. Now, these positive electrons from positive it has to go to negative. Am I right? Example, I'll tell you. See here. Just for an example, I'll show you. This is my small simple circuit. I have connected to a resistor or let me say called as a bulb. Okay. Let me have a switch here. Now this is my positive terminal and this is my negative terminal. The current start flowing. It means the charges, the electrons start flowing from positive side and it will comes to negative side. The electrons start flowing from positive terminal of the battery to the negative terminal or negative side of the battery. Am I right? Now even here also from this positive terminal the charges are coming here. They have entered here. Now these positive charges want to go to which side? Negative side. When they are moving towards the negative side, as you can see in this we have a copper sulfate solution. So these electrons, these charges are helping to copper to deposit on this. Copper will deposit here. When it is moving, when these positive electrons are moving this side, when the positive charges moving this side, it helps the copper because copper is also a positive. In copper sulfate solution, Cu is positive, SO4 is negative. Clear? So these charges helps to deposit copper on this surface. Understood? And sulfate and the sulfate is an impurity. It will get settled down here. In this solution, the sulfate which is present, it will settle down in one corner. That we call it as anode mud. That is nothing but an impurity. This is how, then what we do, we remove this electrode outside and we get this copper separately. Understood? From the copper sulfate solution CuSO4, Cu will come and deposit here. Can you see this arrow mark here? It is shown here. Can you see here? Cu2 plus. Understood? Cu will come and deposit here. Sulfate will settle down here in this solution and it will settle down in one of the corner. From that we remove that impurity. Yes. Understood. The pure substance when it come and attract here. Now whatever example I'll tell you. You take a piece of paper. Put some iron fillings. Put some iron fillings and some sand also with that. Take magnet near to that iron fillings. All iron fillings will come and attract to the magnet. The soil will left behind. Understood? Even here also, when we pass the charges in copper sulfate solution, all copper will come and deposit here. The impurity is left out behind. That impurity will take it off. That's it. Simple method. Concepts are clear? Is the concept is clear? Children, here most of the questions will be asked in the different forms. Okay. I'll tell you which are the forms. They will ask you this question. What? Anode. At anode we have impure copper. At anode what we have? It means in this we have impure copper. In this we have filled with impure copper. Okay. अभी इसके अंदर anode के अंदर क्या है बेटा? Impure copper है. Then what happens here? Cathode, strip of pure copper. The pure copper will come and settle down this side. The pure copper will come and settle down this side. Am I right? At anode we have impure copper. At cathode we have pure copper. Clear? Now what is electrolyte? In this, can you see the solution we have kept right here? We have dropped the solution now in this. That is called as electrolyte. That is the solution of acidified copper sulfate. That is called as electrolyte. Understood? Now, how this reaction happens? They may ask you, briefly explain this process. Then see the steps here. On passing the current through electrolyte, the impure metal from anode dissolves into the electrolyte. अब ये impure copper है नहीं क्या बेटा इसमें एनोड में, ये impure क्या कॉपर क्या होता इसमें डिसॉल्व हो जाता किसके अंदर एसिडिफाइड कॉपर सोल्यूशन के अंदर क्या होता है डिसॉल्व हो जाता. I'll show you once again. See here, see the steps here. Children, if this question appears, it carries 4 marks. You have to draw this diagram and also you have to explain this process. So how you are supposed to explain this process, I am showing you here. Okay. So we have a tank. Am I right? Here we have anode. Here we have cathode. Correct, no? This is my anode and this is my cathode. Am I right? Sure. Sure. See this. Anode, cathode. Now what I am doing here? Observe here. In this, I am going to add impure copper. Impure copper इसमें डाल दूं मैं, जैसे कि कॉपर ऑक्साइड, ऐसा impure copper इसमें मैं डालकर, ठीक है. And in this I have acidified copper solution. This is an electrolyte. This is an electrolyte, acidified copper solution. Once by passing the current to anode, passing the current through anode, understood? This impure copper will come and dissolve in this acidified copper sulfate. It will come and dissolve here. Impure copper will come and dissolve here. Any doubts still here? From this it will come out and it will dissolve in the acidified copper sulfate. Now an equivalent amount of pure metal from the electrolyte is deposited at the cathode. From this whatever the pure copper was there, from this, in this whatever the pure copper was there, it will come and deposit at the cathode. From the electrolyte, whatever the impure copper was there, it will come and deposit at the cathode. Next, whatever the insoluble substances are there, whichever the insoluble impurities. Example, sulfate is an impurity. Why is it called as impurity? Because it is not going to dissolve, so it is impurity. Sand will dissolve, soil will dissolve, it is impurity. It doesn't have any chances to move, to go and deposit here. So that will come and deposit here in one corner. The insoluble impurities settle down at the bottom of the anode. So we call them as anode mud. So we call that as anode mud. Understood the process? Difficult? Simple, no? In one tank we have added impurity. Impure copper. That impure copper, because of the charges, because of the current what we are passing, understood, that current, it has to move from positive to negative. During this process it will push us complete what we say that which no man, this one impure copper from the anode, it will come and dissolve in the electrolyte, and from that electrolyte these charges will help to go and the pure copper to go and settle down at the cathode side, and the impurity which is insoluble, and it will come and settle down at the bottom of the tank. That is called as anode mud. This is how we extract the pure copper. That's it. Okay. The next topic is corrosion. What is corrosion? The surface of some metals such as iron is corroded when they are exposed to moist air for a long period of time. That is called as corrosion. See children, for an example, I'll tell you. The air which is available now in our atmosphere, the air which is available in our atmosphere, that is not a dry air, and also it is not a wet air. ड्राई का तो क्या बेटा, उसमें कुछ भी वाटर कंटेंट नहीं रहना, दैट इज ड्राई. वेट एयर का मतलब क्या, जैसा बारिश आता, दैट इज वेट. अब हमारे पास जो हवा है एटमॉस्फेयर में, इट इज मॉइस्ट एयर. इट इज कंप्लीटली नॉट ड्राई, इट इज नॉट कंप्लीटली वेट. इट इज मिक्स्ड, ड्राई एंड वेट, बोथ इज मिक्स्ड in this, so it is moist air. Clear? Have you noticed one thing? When you are driving a bike with a greater speed, or when you are traveling in a train with a high speed, when the train is moving, you come and stand near the door. The air will start blowing. You can see your hairs will standing. Now, after some time, you just come back, you can see some water droplets will be on your face. The rain was not coming. Only the air was moving. It was touching your body and it was moving. Understood? Some water content will be settled down on your surface. Because when the air was moving, even in our atmosphere also, example, take your home gate, the gate of your home or the windows of your home or the doors of your home. Always it is in the moist condition. Moist air is always it is coming and hitting and going. Once if the air comes and hit and when it moves, from in that air, the wet content which was present, it will come and deposit. Only dry air will go out. Moist air will come, hit the surface. After hitting the surface, it move away. From the, in that moist air, whatever the water content was there, it will deposit. Like this water will start reacting with that metal. Now metal will react with water here. No metal. What is happening? Yeah. It is reacting with water. Then what happens? Metal hydroxide will form. In last class we have discussed, right? When metal react with water, metal react with steam. Remember? When metal react with water, metal hydroxide will form. When metal react with steam, metal oxide will form. Aluminum oxide example I give you. Clear? Yes. Here also this metal hydroxide will form. This metal hydroxide formation is nothing but corrosion. So the metal will change its properties after certain time. First it was pure iron. After some time, that metal when it's striking with that moist air, because of that, the reaction will take place. Because of that, certain reaction will take place between that iron or between that metal and that moist air, due to which it changes its properties. Earlier, that metal has certain properties. After a few days, the metal doesn't have that property because it has changed to some other form. Due to the change in the form, the properties also will changes. The metal loses its luster, the shining will go. Metal loses its hardness, so that it will start getting cracked. Cracks आ जाती है उसके ऊपर. उसका hardness चले जाता है. जब उसके अंदर का hardness चला गया, so it will start cracking. Once it gets start cracking, it loses its property. It loses its property that is said to be corrosion. Understood what is the meaning of corrosion here? Yes, sir. Now, see here, children, these three are very important examples. Remember, silver becomes black. अब सिल्वर में corrosion हुआ तो कौन सा कलर आता है तो पुस्ती मिटा एग्जाम में. सिल्वर में corrosion हुआ तो क्या चेंजेस दिखाई देती. कॉपर में corrosion हुआ तो क्या होता. आयरन में corrosion हुआ तो क्या होता. They will ask you this question. And also their colors is important. Also their colors are very important. When silver becomes black when exposed to air, it means in silver if corrosion takes place, silver become black. And also you might have seen when you are wearing a silver chain, after some time you can see that silver chain will start black. Some black coating will come on the silver chain. Have you seen? Silver ring, silver chain. Have you noticed? Yes, children, that is what. Silver becomes black when exposed to air as it reacts with air to form a coating called as silver sulfide. उसके ऊपर silver sulfide का coating आ जाता है. उसके बाद से उस पर corrosion start होता है. उसके properties change होती है. जब silver के ऊपर एक black color का color आ जाता तो उसमें silver क्या होता? Corrosion होता उसमें. उससे हमें क्या बोलते हैं? Silver में corrosion हुआ तो उसका नाम क्या? Silver sulfide. Since silver sulfide will form over there, so we call it as corrosion in silver. Similarly, copper reacts with moist carbon dioxide. Copper किसके साथ react होता? Carbon dioxide में. Where is carbon dioxide is present? In the air only. Where is oxygen present? In the air only. Air में oxygen भी है. What is air? It's a mixture of all gases. Air का मतलब क्या बेटा? It's a mixture of all gases. पूरे gases mix होने के बाद air बनता है. तो air के अंदर carbon dioxide भी है. Air के अंदर oxygen. Clear? But here, when carbon reacts with the moist carbon dioxide in the air and gains a green coat, कॉपर के ऊपर एक ग्रीन कलर का कोट आ जाता. हैव यू सीन? घर के अंदर तांबे के देक्षिया वगैरह देखो ही बेटा, पुराने देक्षिया वगैरह, उसके अंदर एक ग्रीन कलर का कोट आ जाता उसके ऊपर. दैट इज नथिंग बट कॉपर कार्बोनेट. दैट इज नथिंग बट कॉपर कार्बोनेट. अंडरस्टूड? And similarly, we have iron. When iron is exposed to moist air, It acquires a coating of brown flaky substance, brownish. That is called as brownish red. What we call it as brownish red. Brownish red surface will come. That is called as rust. Rusting. Rusting of iron. Rusting in iron. Understood the concepts? In silver, black color will form, silver sulfide. In copper, green coat will come, that is copper carbonate. In iron, brownish red will appear, that is called as rust. If brownish red color has formed on the surface of the iron, that is nothing but called as rusting. Now, how do you prevent it? How can we prevent it? See, children, prevention of corrosion. How can we prevent? The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome paint plating, anodizing, or making alloys. By using these methods, we can prevent corrosion. Now, in this, we have used the word galvanizing. You know very well about painting. Paint it. You prevent corrosion. Oiling. Apply oil. No corrosion. Greasing. You apply grease. I hope you have seen for the cars. We put grease. No? Some wax kind of substance will come. Grease लगाते थे क्या जी? व्हील्स के पास में सभी ग्रीस डालती है, वायर्स के पास में क्लच प्लेट के पास उधर सब ग्रीस अप्लाई करती है. क्यों? करोशन नहीं होना बोल. And galvanizing. What is galvanizing? It is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. Zinc coating कर. समझ गए बेटा? जैसे कि फॉर एग्जांपल व्हेन यू परचेज ए कार, कार परचेज करते नहीं बेटा, कार की जो नीचे की बॉडी है, दैट बॉडी, देखो बेटा, ऊपर की बॉडी जल्दी रस्ट नहीं पकड़ती है, लेकिन नीचे की बॉडी है ना जल्दी रस्ट पकड़ती है. बिकॉज ऑलमोस्ट एवरी टाइम द बॉटम लेयर ऑफ द कार क्या होता, पानी के साथ रिएक्ट होते रहता. रोड के ऊपर जो पानी पड़े ना, वो पानी उसके ऊपर उड़ते रहता ना, तो जल्दी रस्ट पकड़ने की चांसेस ही. तो उससे ना क्या बोलती, सर हमें जिंक कोटिंग कर दी, उसके ऊपर और एक कलर का एक कोटिंग अप्लाई करते हैं. वो कोटिंग क्या करता बेटा, यू कैन सी वेन एवर दैट कोटिंग इज डन, नो एक्चुअली हमारा नीचे का बॉटम स्मूथ रहता है, जब कोटिंग करे तो रफ हो जाता सरफेस. यू कैन सी दैट इज कॉल्ड एज जिंक कोटिंग. by using that zinc coating we can prevent from rusting for iron and steel. Next, by alloying. What do you mean by making alloys? What is an alloy? Very important question. An alloy is a homogeneous mixture of two or more metals or non-metal. जब दो या दो से ज्यादा मेटल्स और नॉन मेटल्स को कंबाइन करने के बाद आपको जो प्रोडक्ट मिलेगा, दैट इज कॉल्ड एज अलॉय. Very important. Very important. They will ask you this question for 4 marks. It's a 4-mark carrying question, children. They will ask you what is alloy, and sometimes they will ask you, okay, one table you have to form here. You have to frame one table. Okay, write the name of the alloy, their constituents, and their uses. You have to make a table. Alloy के नाम, उसके अंदर constituents. Constituent means what are the materials you are using. Means which are the metals or which are the non-metals you are using to make that. Example, you take steel. Which steel? Actually, it is stainless steel. If you want to make stainless steel, if you want to make brass, if you want to make bronze, if you want to make solder, or if you want to make amalgam. Understood? These all are what? These all are alloys. To form this alloy, what are the materials we are using? These are all the materials. These all are the materials we are using. Now they may ask you, what is the use of stainless steel? What is the use of brass? Where are we using that? Bronze, solder, amalgam. Any doubts? But here, among these all, the most important thing is, the most important one for you all guys, for the examination point of view, that is, I'll let you know. Stainless steel, brass, bronze, solder. These are the 4 important things for materials and uses. About amalgam, just they will ask you, what is amalgam? That's all. What is amalgam? That's all they may ask you. And why do we use iron? That is natural thing. You can tell that. But among these 1, 2, 3, 4, these 4 are most important topics. Don't forget. These four are most important topics. कॉन्सेप्ट सा क्लियर? हाँ बेटा, अब इसके अंदर एक इंटरेस्टिंग टॉपिक है बेटा, इंटरेस्टिंग बात है. व्हाट इज दैट इंटरेस्टिंग बात मीन्स? सिंपल. सी हियर, if you want to make stainless steel, I'll give the logic in Hindi. Understood? Stainless steel. आयरन को, आयरन मीन्स Fe, आयरन को मैं निकल बाहर कर को बोलिया तो क्रोमियम के जैसा चमकना शुरू होगा. Cr इज क्रोमियम, Fe इज आयरन, Na इज निकल. आयरन को मैं निकल बाहर गया, निकल गया तो उन्हें क्या कर क्रोमियम के जैसा हंसना शुरू कर लिया. स्माइल. क्रोमियम मीन्स शाइनिंग. स्टेनलेस स्टील आयरन को निकल कर को बोले क्या कर क्रोमियम के जैसा चमकिया. एनी डाउट्स? नेक्स्ट इज ब्रास. कुत्ते को जब जंग पकड़ लिया तो उसमें बास आना शुरू हो गया. कुत्ता मीन्स कॉपर, जंग पकड़ लिया मीन्स जिंक. सो कॉपर प्लस जिंक वी गेट ब्रास. नेक्स्ट ब्रॉन्ज. ओके, कुत्ता मीन्स कॉपर, खा को टिन के जैसा हो गया. दैट इज Sn इज टिन. कुत्ता मीन्स कॉपर. कॉपर प्लस टिन विल गिव ब्रॉन्ज. सोल्डर, वेल्डिंग करना बेटा. सोल्डर हैव यू सीन सोल्डरिंग, वेल्डिंग? हाँ, क्या करना? in that welding example, this is my welding rod. This welding rod is made up of a lead. This understood? अब वेल्डिंग रॉड लेको क्या करें? टिन को वेल्ड कर रहे हैं. टिन को क्या करें बेटा? वेल्ड कर रहे हैं. दैट इज Pb plus Sn. We get solder. We will get solder. Yeah, children. I hope you have understood. And similarly, as you can see, we have one more alloy that is called as amalgam. If one of the metal is mercury, if it is present in that is called as amalgam. That's it. Now see here, you can expect the questions like this. Green color coating on copper utensils is due to the formation of green color coating has come on copper because of copper carbonate, copper hydroxide, copper oxide, or none of this. Copper, where did we study? We study here. Can you see this? Copper reacts with moist carbon dioxide in the air and gains a green coat called as copper carbonate. Because of copper carbonate, green color coating has formed on the copper. Because of silver sulfide, black color coating has come on the silver. Clear? Because of brownish red, understood? The rusting takes place on iron. Remember, no? Yeah. Rusting of iron takes place in ordinary water, distilled water, both A and B, or none of this. Interesting question. Rusting of iron, rusting off from takes place. Okay, rusting will take place in ordinary water, distilled water, both A and B, or none of this. Children, I want the answer in the next comment section. So, question number 2, what is the answer? I want the comment. Let's see who all going to answer. Similar, 1 minute. Question number 3, silver articles become black on the elongated exposure of air due to, when you expose to air, silver articles are becoming black because of Ag2O, Ag2S, AgCN, or none of this. Let's see your answer. What could be the correct answer? Aluminum strip is dipped in ferrous sulfate solution and change that observed is green color changes to brown, lower end of the tube becomes warm, color gas with burning of sulfur, and none of this. Hey, by seeing here it told the answer, man. So the first answer is option A for the first question, copper carbonate, and the second option is option C, both A and B. Rusting will take place because of both ordinary and distilled water. And number C, silver articles become black because of silver sulfide, Ag2S. Remember, silver sulfide. And aluminum strip is dipped in ferrous sulfate solution. That it changes. What can we change? None of this. Why it is none of this? Because as you can see, when aluminum reacts with ferrous sulfate, what's going to form? Aluminum sulfate plus iron. Am I right? 1 minute. Very good. I'll understand now. Your basics. Let's see. Aluminium is dipped with ferrous sulfate solution. Then we will get aluminium sulfate plus ferrous. Correct, no? Yes, sir. My dear students, before answering such type of question, I want you have to do one small revision before telling the answer for this. का ना को मंजे आलू लाना जिद करे तो लोहा पकड़ को घर में घुस को मार तो आओ जी आओ जी आओ. Now look at here. Where is Ag? Sorry, where is aluminium? Here, aluminium. Where is ferrous? Iron? Here. Now, as you can see, aluminium is highly reactive metal. Iron compared to aluminium, iron is least reactive metal. A highly reactive metal can displace least reactive metal. Yes. Then this reaction is possible. Since this reaction is possible. Now, what is the product will form? What do we observe? On aluminium, we get the sulfate coating. Aluminium sulfate has formed. Here, can you see this green color changes to brown? Lower end of the tube becomes warm. Color gas with burning of sulfur. Are you finding any of this here? What is the change we are finding? We are finding the changes aluminum sulfate. If here any of the option gives aluminum sulfate as formed or any iron is displaced, they are telling no. So none of this. Okay, guys. So fill in the blanks. Rocky material found with ores is known as rocky material, hard material found with the ore, found with ores is known as yes. Corrosion of iron is called rusting. Electrical conductivity of alloy is that of pure metal. The alloy in which one metal is mercury is called. When on alloy we have one mercury that is called as amalgam, bubble gum. Non-metal used for preserving the food material is. I want the answers for these questions and very short answers. Name the metal that is highly resistant to corrosion. Define galvanization. Name the non-metal that is used in rocket as a fuel. Name the non-metal used for conversion of vegetable oil into vegetable ghee. Give the necessary conditions for rusting of iron. Metal react with water. What it will give? Metal react with dilute acids. Remember standard form. When metal react with dilute acids, what they will give? School bells are made up of metals. Give reason. Remember, I gave the examples. Because they produce sound. Like that. Name the following. A metal which is preserved in kerosene. A lustrous colored non-metal is. It is lustrous. It has a shining. Still, it is non-metal. Iodine. A metal which can melt on palm. Keep on palm also it will melt. No. Mercury. Okay. Potassium. Sodium. It can be cut with a knife. A metal which is the poor conductor of heat. It is metal, but still it is a poor conductor of heat. We have discussed all the metals are good conductors. Some metals are there which are poor conductor of heat in physical properties. Yeah, anyhow. Same two metals that are soft that can be cut with a knife. Number of electrons, excuse me. Don't tell the answer. I want all these answers in the comment section. Okay. Number of electrons gained or lost by an element is called. What are minerals? What is the process of depositing zinc on iron is called? Which metal do not react with water at all? Name the ion made by non-metals, cation and anion. Bronze is an alloy made up of dash and dash. Name two metals that are stored in kerosene oil. Arrange copper, silver and aluminum in increasing order of their reactivity. Increasing order, which is least, next highest, next highest. Increasing order. Statement 1, they have said metals oxides are basic in nature. Statement 2, metal oxides turn red litmus paper to blue. Tick the correct one. Which among this is the correct answer among these four options? Statement 1 is correct, but 2 is wrong. Statement 2 is correct, but 1 is wrong. Both statements are correct, or none of them is correct. You have to tell the answer for that. So this kind of question, this is called as assertion and reasoning questions. Clear? Again, statement, metals are sonorous. Steel is an alloy. Take the correct answer. Statement 1 is correct, but 2 is wrong. Statement 2 is correct. Metals are sonorous. Yes, sir. Steel is an alloy. Yes, sir. Just now we have discussed stainless steel. Yes, sir. Steel is nothing but yes, stainless steel. Okay. Statement 2 is correct, but 1 is wrong. Both are correct. And none of them is correct. Any doubts? Any doubts? No, sir. Next short answer type questions. Give reasons. Why is gold not suitable for making ornaments? Because it is available in free state. Yes, sir. Understood. And it is in a molten state. See, pure gold, it is in a molten state. Example, have you seen your toothpaste? Yeah, pure gold, it will come in that form. In that form, which chain you can make? You can't make. So we will add some impurity in that to make it hard. By using directly pure gold, we cannot make any ornaments. We have to add some impurity. Understood? Yeah. Why calcium is formed? And even you can see, we say 24 karat gold, we say 22 karat gold, we say 18 karat gold. Now, what is the difference between these? I am just giving small example. It's not accurately correct. Example. In 24 karat gold, example, 99% gold, 1% impurity. Example. In 22 karat gold, assume 85% gold, 15% impurity. In 18 karat gold, 75% gold, 25% impurity. And as you can see, as the carat decreases, impurity increases. Now they are charging on the percentage of gold value for you. If 24 karat gold is around 12,000, then believe me, 22 karat gold will be around 11,000. And 18 karat gold, it will be around 9,000. Because the quantity of gold changes here. The gram of gold will change. The quantity of gold will change. Am I right? So this is what understood the difference between all the types of golds. Why electrical wires are coated with PVC, polyvinyl chloride? They are coated with PVC. Electrical wires are coated with PVC. Yes, sir. Okay. Why do we apply oil on iron tools kept in storage? Yes, sir. Iron tools, we put oil for them. Yes, sir. Why sodium is stored in kerosene oil? Why cesium and gallium melt in our palm? Why magnesium ribbons start floating in hot water? Yes, sir. Yes. What are ionic compounds? Complete the following reactions. To obtain metal from their metal oxide, which chemical process is used? To get metal oxide. Metal oxide. Yes, which process is used? Give the chemical equation as well. With respect to electrolytic refining of copper, answer the following. Name the electrolyte. We have seen the table, right? What is the name of the electrolyte we are using? Purification of copper. Anode, cathode, we have seen, right? Is that electrolyte? Acidified copper sulfate solution. That is an electrolyte is used. Remember? Name the anode and cathode. At anode, what is there? At cathode, what is there? Yes, at anode, impure copper. At cathode, pure copper. Reaction of anode and cathode. At anode, what is happening? At cathode, what is happening? Yes, sir. Write the steps involved in this reaction. Similarly, as you can see here, question number 8 and 9. Yes. Okay. My dear students, if you are not subscribed to our YouTube channel, Shah Sir classes, kindly do subscribe it and click the like button. And do not forget to comment how was this class and what benefit did you get out of this class and this session. Okay. Anyhow, question number 10 and 11 also you can see some give reasons questions are given here. I want you have to go through these questions. These all are examination based questions. 100% believe me, it will be very important and useful for you all guys. Clear? And also some chemical equations I have asked and 5 mark carrying questions. Difference between mineral and ore, roasting and calcination, process in metallurgy. What is metallurgy? The process we use to extract pure metals is known as metallurgy. That is electrolytic refining or reduction method. That the complete process is known as metallurgy. Okay. And these are the hints for long answers that I want from your side. the answers for all the long answers. Okay, anyhow, guys, thank you for watching this session. Hope you have got a benefit out of these Shah Sir classes. And the admissions are opened in our coaching institute, Evershine Coaching Center. It is located in Bangalore near Tannery Road. If you want further details about our institute and the classes, which is held from 1st standard to 12th standard for all the boards ICSE, CBSE, and Karnataka State Board. Okay. If any students are interested to join from class 1st to class 12th, you can contact below in the description. The details are given. Thank you. Take care. All the best. See you soon with the next session.